Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 1 class. It is 9.6 day 2, where we will compare the two different ways to factor a trinomial. One where there is no number in front, and the other way is when there is a number in front. So when we have a coefficient or the number in front is 1 for our trinomial, like this form here, x squared plus bx plus c, we only need to use 4 steps. First, we need to break up x squared. The only way to break up x squared is x times x, and we're going to put that at the beginning of our parentheses. In this case, it says put the square root of the first term, it's usually x, in the first positions. Okay. Next, we need to find the possible two number combinations whose product is c. So this is where we take the factor tree of our last term, which we call c until we actually know what it is. So that's talking about factor treeing out c. Then for the third step, we need to find the two number combinations whose sum is b and is the same as one combination from 2. So we need to figure out what adds to our b term, okay? Finally, we will check using FOIL to make sure that we got back to what the original problem was saying. That is when we do not have a number in front. Now, if the coefficient is a number other than 1, we have the form ax squared plus bx plus c. This is when there is a number in front. The first step is to see if there is a GCF. Because I have a number in front, it is possible for me to have a GCF, so we want to check and see if there's a GCF. After we have checked to see if there's a GCF, we are going to factor tree our ax squared factor. We're going to factor tree our ax squared term, okay? So that very first term, we're going to get a factor tree of that. Step 3 then is to make a factor tree for our c term, the last number in our problem, the c term, okay? At this point, what I want to do is I want to find the combination of terms from ax squared and c that when they're multiplied together will add to my bx term. Okay, so that's where we kind of go off to the side. We take a 2x from our first term and a 3 from our second term. We find out that's 6x. Then we figure out another two numbers that will multiply together, and we see if their products will add to our bx term. Okay. Then we'll put it into our double parenthesis form, and then we will check using FOIL. First, outer, inner, last. Double distribution is really what we're doing there. Remember that during step 4 is when we'll also figure out the signs for our numbers we're going to use, okay? All right. Now, try these problems below, check using FOIL. So the first one, we do not have a number in front. So all I have to do is factor tree out this 10. So I have 1 times 10, 2 times 5. The sign of the middle term, the negative, goes to the larger numbers. How do I make negative 10 turn into a positive 10? My 1 has to be negative. So all of my smaller terms would also be negative. Which one of my sets here would add to negative 7x? It's going to be negative 2 and negative 5. So we have x minus 2 times x minus 5. Okay? That's the first problem. Now on to 2. I have 3 in front. I have 3x squared as my first term. So I need to check and see if I have a GCF. So is every number 3, 4, and 15 all divisible by the same thing. In this case, the only thing they could be divisible by is 3. So 4 is not divisible by 3, meaning that I do not have a GCF. So I'm going to make a factor tree of the A term, make a factor tree of the C term, and I have to figure out what combination is going to work to get me to this negative 4x. Now remember, if there's a negative in the back, I actually want to multiply to something larger than 4. I want to multiply to something larger than 4 in order to then come back down to 4. So what I'm going to do is I'm going to take this 3x times 3. Take 3x times 3, that gets me 9x. Since I use the 3x, I have to use the x. And since I use the 3, I have to use the 5. That gets me 5x. Well, how can I make 9x and 5x get me negative 4x? Well, in order to do that, my 9x has to be a negative, which means that my 3 has to be a negative. Okay? At this point, I know that I would be good. So I'm going to put my 3x first. I'll put my x in the first position in the second set of parentheses. The 3x multiplies by negative 3, so negative 3 has to go in the second set of parentheses. The x here is going to multiply by 5, so that has to go in the first set of parentheses, and I am done. The one thing that you do want to check to make sure that your signs are correct is I'm going to take 5 times negative 3, and I want to make sure that gets me to negative 15. I already know my combinations get me to negative 4. Negative 9x plus 5x gets me negative 4. So I know that's fine. I just want to double check that I'm multiplying to negative 15 as well. Okay? 3, again, I do not have a number in front, so I'm just going to make a factor tree for 12. The sign of the middle term is negative, so all of my larger numbers are negative. They need to multiply to a negative, so all of my smaller numbers would be positive. What combination can get me to negative 4? That's going to be positive 2 and negative 6. So I have x plus 2 times x minus 6. Okay? On to example 4. 1 times 9, 3 times 3. The sign of my middle term is positive, so my larger numbers are positive. They need to multiply to a positive, so my smaller numbers need to be positive. What will get me to 6x? It's going to be this positive 3 and positive 3. So x plus 3 times x plus 3. On to 5, the last one in this column. Again, I have no number in front, so I can just make a factor tree here. The sign of my middle term is negative, so my larger numbers are negative. The sign of the back is negative, so my smaller numbers need to be positive. What can get me to negative 8? It's going to be negative 9 and positive 1. So x plus 1 times x minus 9. All right, and each one of those we could use FOIL to check, but we do not have to do that at this point in time. On to 6, we have a number in front, so I need to check for a GCF. 3, 5, and 2. The number that they would have to be divisible by is 2, because that's the only number 2 can be divided by. In this case, 3 is not divisible by 2, so I am on to making a factor tree for both. Okay? Again, my sign in the back is negative, meaning I want to multiply to a number larger than 5. There's only one way to do that, and that's to use 3x times 2. When I use 3x times 2, I get 6x. Since I use 3x, I have to use x. Since I use 2, I have to use 1. That gets me a single x. Now, how can I make 6x and x into negative 5x? That's by making the 6x negative, which means my 2 has to be negative. Negative 6x plus x would be negative 5x. And now on to how do I put it into my 2 sets of parentheses. I'm going to put my 3x first. That multiplies by -2, so -2 has to go at the end. The x then goes in the first position in the second set of parentheses. It multiplies by +1, so that goes in the first set of parentheses as well. All right. On to 7. 7 does not have a number out front, so I just have to make a factor tree. I believe that's everything that we have there. My sign in my middle term is positive, so that means both of my larger numbers are positive. It has to multiply to a positive, so my smaller numbers are positive. What then would get me to positive 12x? It's going to be +3 and +9. X plus 3, x plus 9. Okay. On to 8. I look for a GCF. 9 is not divisible by 5, and 5 is the only number I could use, so that will not work. So 9x times x for the first term, 3x times 3x for the second term, and 1 times 5 is all I have for this. Again, I have a negative in the back, which means I want to multiply to a number larger than 12. I could do 9x times 5, but if I do 9x times 5, I'm going to end up with 45, which is so far away from 12x, I'm just going to kind of throw it out the window for now. So what I'm going to do is 3x times 5, which gets me 15x. It means I have to multiply 3x times 1, which is 3x. Well, how can 15x and 3x get me to 12x? One of my numbers has to be negative. That's how I get to a negative in the back here. Well, that would be a +15 and a -3, meaning this 1 has to be negative. Go ahead and put it together. 3x, 3x, plus 5, minus 1. What's nice about having the same x term in that situation is it doesn't really matter where you put the 5 or the -1. Okay. On to 9, again, I do not have a GCF because 13 is not divisible by anything. So I have to make a factor tree for my first term and my second term. 1 times 6, 2 times 3. Now, I have a positive in the back, so this time I want to be smaller than 13. I want to multiply to a number smaller than 13. So 6 times 6 is obviously out. I can't use 6x times 6. I want to look at something smaller than 13 that will work for me. If I do 6 times 2, I end up at 12x. And then 3x times 1 would be 3x. Well, 12x plus 3x would get 15x. So that's not going to work for me. So the 1 times 6 situation is kind of out the window here. What I then could do to get really close to 13 is 3 times 3. So I can do 3x times 3, which is 9x. I can do 2x times 2, which is 4x. Is 9x plus 4x 13x? Yes, it is. So now I just have to put it together. So 3x goes at the beginning. 3x multiplies by 3. That means +3 has to go at the end. Remember, the x's always go first in the parentheses. 2x multiplies by 2. So this +2 has to go in the other set of parentheses. And I am done. Now on to 10. This is the first time that we have found something that looks like it might have a GCF. So let's look at this. The only thing I can divide 2 by is 2. So is 14 and 24 divisible by 2? Yes, they are, meaning I have a GCF of 2. So I go ahead and take out my 2. 2x divided by 2 is x squared. -14x divided by 2 is -7x. +24 divided by 2 is +12. Now, what that does for me is this gives me a new problem where I do not have a number here in front of the x squared. And since there is no number in front of the x squared there, I only have to make a factor tree of 12. So 1 times 12, 2 times 6, 3 times 4. Looking for something to add to -7. So the sign in the middle is negative, meaning my larger numbers are negative. I need to multiply to a positive, so the smaller numbers also would have to be negative. What combination get me to -7? -3, -4. So I need to bring down my 2, which is my GCF, parenthesis, x minus 3, parenthesis, x minus 4, and I am done. Okay? Let's move on to the last column. What I want you to do is I want you to go ahead at this point and I want you to try 11 through 15 on your own. You have 2 that have a number in front. You have 3 that do not. So go ahead, pause the video right here. Try 11 through 15 on your own. Make sure you're showing your work. And when you come back, I will have the answers for you. All right? All right, welcome back. So for 11, I got x minus 11 times x minus 2. I needed to multiply to a positive, add to a negative. So both of my numbers needed to be negative. 11 and 2 get me to 13, so I'm good there. For 12, I had 4x squared plus 4x minus 15. In this case, I looked for a GCF. There was not one. 15 is not divisible by 4. So I made a factor tree for 4x squared. I made a factor tree for 15. What I was looking for, since I have a negative in the back, is I was looking for a number that I could multiply to that would be larger than 4x. So when I did that, I multiplied 2x and 3 together, which got me 6x. And then 2x times 5 got me 10x. Since I had 10x and 6x, I was able to make positive 4x by making the 3 negative. For 13, you have the number 16. I needed to multiply to a positive, so both of my numbers needed to be negative since I had to add to a negative. So x minus 4 times x minus 4. You could leave it as x minus 4 times x minus 4, or you could turn it into x minus 4 squared. On to 14. I had to multiply to a negative and add to a positive. So my larger numbers were going to be positive. My smaller numbers were going to be negative. I figured out that 5 and -2 were able to multiply to -10 and add to positive 3. And then 15, again, I did not have a GCF. I wanted to multiply to a number that was larger than 6. So I tried 3x times 4 was the first thing I tried. That got me 12x. Then I had to multiply 3x times 2, which would have gotten me 6x. So 12x minus 6x got me positive 6x, meaning that I had to make my 2 negative. So if you have any questions on those 5 problems, please make sure you let me know, and I will try my best to go through them with you. Otherwise, thank you very much for watching the video, and have a great day.